Good day, welcome to this video. In this video, we're going to analyze the tips dataset using Pandas and Plotly Express. The first step is to import the necessary library, in this case Pandas, and then Plotly, looking at the Express module. Of course, there are other modules in Plotly other than Express. I just find Express to be very easy to use, and that's why I'm demonstrating it here. The ask keyword creates the alias, so PD and PX. So let's run that. For these data sets, let me show you right here. We have a lot of data sets here. We're going to be using the tips data set. It is a Kaggle data set. And we do this. We can use the sample keyword to just get a feel for what it looks like. We can run it again. We see that the size, number of people in the dinner party, the time, whether it's dinner, lunch, what day, is the person a smoker, what's the gender, what's the tip amount, and what was the total bill. So we can use the info keyword here to look at things like what is the data type for the individual columns, how many nulls do we have, if any, and then things like this, right? So we see we have 244 entries. It says we have 244 non-null. Non-null means essentially there's no missing data in any of these columns, which is always a good thing. Now the shape attributes, what it does is it tells us the number of rows, which you already know from the info, and gives us a number of columns. We have 7 columns in this case. If you call the columns attribute as well, it gives you in an array format the total bill, the tip, the sex, the smoker, the day, time, size. All the information is provided here. Now the drop duplicate function in Pandas helps to actually drop duplicates. So sometimes you might have a row of data that is repeated for whatever reason, and the drop duplicate takes those rows of data out. Now another thing you could do is you could specify the subset in that row of data. So if you wanted to just be a subset, maybe like to check if 2 or 3 columns are exactly the same, to mark it as a duplicate for removal or not. But in this case, the default is check if every column is duplicated in different rows, and if it is, let's take it out. So after doing that, we see that the shape, oh my bad, let's run this. The shape reduces to 243 rows and 7 columns. So 1 row was taken out, which is fine. Now in the EDA section, there are several things we can do. We can start with univariate analysis, making some single column plots. Now you might not be able to always do this, but I think it's a good thing if you can, especially in a case where the data set is this small. We can actually look at that. So let's just create a markdown here. All right. We want to look at the total bill. So I want to look at the total bill by itself and then look at it in different dimensions. So let's look at its distribution using the histogram. Let me put some space here. Okay. So we'll say total bill hist. You could do this, or you could just name it plots like convention. Call the histogram function. We need to specify the data frame. In this case, it's df. We need to specify, whether we want it to be plotted on the x-axis or the y-axis. Doesn't matter. What do we want to plot? In this case, we want to plot the total bill. So let's just copy this, save ourselves the time from having to type it. We'll copy it, place it right here. You need to give it a title, distribution of total bill. Okay. And with this default, we should be able to show a diagram. Let's see. Now at this point, if you have an issue with getting this to actually show, you might need to install certain other libraries within your notebook. So I'm going to give you the names of the library. I'm going to try to put it in the description somewhere in the video. So just in case when you run this and everything is correct and it just doesn't display, most times it means you need to install some other libraries and some other software to just make it work. Now, if that's the case, you don't want to go through all that hassle, you could go ahead and copy all this code, put it in a regular Python script. As long as Plotly is installed and Pandas is installed, the script should run, and you will be able to see this visual come out. So 2 options for you. So this is what the distribution looks like. Now we see the majority of the bill is between $16 and $18. There are about 32 of them. And we can decide to increase the number of bins. Let's say we want it to be 50 bins. Let's just see. So it's a little more granular. So we still have the majority of the bill coming to be between $16 and $17. There's 18 of those. And then you have some bills where some people spend between 48 and 49. If we decide to maybe use 10 bins, we could do this as well. It's a little less granular and it puts a lot of things into brackets. So you see between $15 and $20, that's what most people spend. There are 67 counts there. And then between 10 and 14. So it all depends on you and what you're trying to do. Sometimes if in doubt, you can always use the default bins value. That's totally fine. So that's it when it comes to this. But I think I'll stick with this one. There are a lot of other things you can specify, but for now I feel like this good enough. Like, so for example, you can change the colors and all that stuff. Let's just move on in the EDA section. So we are still on total bill distribution. Sorry, let me change this to a big D, because the rest were in capital. Now we can decide to look at the total bill across different categorical locations. So we know here we have, most times when you see objects, they could be categorical in nature, but when this is objects, it's a string, or it's supposed to be a string. Now you want to know how many unique values there. So we could also do that. For each of them, let's analyze this. Let me just copy that. Copy this entire list. We could look at size as well, even though it's numeric in nature. We can try to look at it as though it's categorical just in case. Let's come here and say we use a for loop for call name. You can call it anything you want, but it's good to always be descriptive. For this, we can do several things. So let's print the column name. Then let's print df call name dot n unique. So how many unique values are there? Print df call name dot unique. And we could also do this print. So I'm using the print statements just because some people might want to run this in their Python environment and I still want it to work properly. But if you're in the notebook environment just like we are, you pretty much don't need to do this. Okay, so let's see this and let's do a print to put like a line between everything, something like this. So see for sex, you have two unique values, male and female and male, and there are 157 male, 86 female. Okay, majority are male. Smoker, no or yes, mostly are non-smokers, a few are smokers. For the day, we have 4 unique values, Sunday, Saturday, Thursday, Friday, so it's not open Monday through Wednesday. And this is the breakdown. Friday has the least amount of people, but Thursday, Saturday, Sunday are kind of around the same, but Saturday has a larger number, larger occurrence. Time, we have only dinner and lunch, so this is not a breakfast place. Majority comes in at dinner. And the size, there are 6 unique values, so 2, 3, 4, 1, 6, 5. Right, these are the values. Majority are a group of 2. Then, next to a group of 3 and then a group of 4. But larger crowds are not common. And then people coming in single are also not common as well. So with this information, we can decide to look at the total bill in this. So let's do this. Matter of fact, let's copy this entire thing. I'll show you can do that in a very efficient way. And so for this, we're going to create box plots. So let's say we want to look at the distribution of the total bill across these 4 categorical dimensions. Now, of course, you could always go a little deeper and not just one at a time, but I think this would be a good one to just show first. So we could say box. See, there's bar. We're interested in the box. And the data frame is df. On our x-axis, it's totally up to you how you want to do it. We could say X, we want the column names to be on the x-axis. Sorry. Y, we want the total bill. Let me see how it's spelled. Sorry. Okay, here. Put this here. Okay, let's give it a title. Yeah. Dimension, that's just a choice of what I am deciding to make. You could call it something else. Put the call name here. And let's not forget to do this. Plot.show. Okay. So this shows across sex, on average, male participants, the median amount they spend is slightly higher than what females spend, 18 to 16.4. That's the median. We do have outliers here, and we have some outliers here as well. We don't have outliers on the lower end, which is a good thing, I guess, for a restaurant. We look at smokers. Now, smokers, non-smokers, not a significant difference. Now, it looks to me like the gender plays a bigger role in what the total bill distribution actually will be. So let's see. Day of the week. We see Sunday has the largest median at 19.6. Saturday is about 18. Thursday is a little slow at 16. Friday seems to have the lowest median value. So a majority of people come really spending on a Sunday. We do have outlier values, so for example, even on a Friday, there was someone that spent $40 on a Friday, which is not the usual. So dinner and lunch, more people spend more money on dinner than at lunch. So there's a $3 difference between both median values. So you start to see, the different time of the day, the different location and all that thing. You can start to see, okay, what is likely, what time of the day is likely. So that's what we can see here. Now for size, we see here that the total bill, it makes sense. We kind of expect this. As the size of the group increases, the total bill overall tends to have an upward trend because, of course, more people in a group tend to spend more money. And you see the medians also increase as well. So this is something we kind of expect, as the size of the group increases, most likely what they're going to spend will increase. Now, the real question will be, will this translate to the tip size as well? We really don't know, but we can always find out. Let me name this to tips. One additional thing you could do if you want to, make things look a little interesting, you could always color it by the variable that is categorical in nature. So that's always an option. You see that? It just makes things look a little more interesting. That's always an option as well. But regardless, it's still the same information that is being passed across, so that's fine. Next, let's move our attention to the tip. So we can just copy this. Let's call this tip distribution. So for this, first thing we want to do is create let's add some more distance here. The histogram, that's always a good first step. You also want to get an idea of what the tip distribution looks like. So we're going to recopy this and use it. We're going to make use of this again, which is fine. Here, paste it. And we'll just say, I don't remember if it's tip or tips. I think it's tips. But whatever it is, if we do get an error, it's just because of the spelling. That's all. Let's see. Is it good? Okay, no. It's supposed to be tip. My bad. So for tip, we see the majority of the tip come to be about between $2 to $3. And then the next is $3 to $4. And then you have $1 to $2. And you have $4 to $5. You have $5 to $6. Now you have some people that give $6 to $7 tips, and then you have some $10 tips, or just one in this case because the count there is one. So we get an idea. Okay, well, most people that come here to tip about $3. So if you're someone that works at this restaurant, you have access to this data, you can almost start to get a sense for how much you are likely to be tipped. Now you see that this data is skewed to the lower end. You see, it's not a normal distribution because, on the higher end, you have less occurrences. But on the lower end, you have these two occurrences essentially. So that's just one thing to know. The question we should now ask ourselves is, does the dimension matter? Are we expecting to see some unique behaviors when it's for a smoker versus a non-smoker? Things like that. So we can do the same thing we did here. I'm just going to copy this code, save us the time, but I will do a walkthrough on this just so that we all can see it. So here we've identified these columns. I think there are 5 of them. 5 columns that are categorical in nature, not necessarily all numeric or all object types. All these are object types. The size is numeric, but it has just 6 unique values, so we want to treat it as a category. And so we're going to use the box plot. Of course, we could use Violin as well. Maybe I'll show the Violin instead of the box plot. We specify the data frame. We specify what we want on our x-axis, which we want the limited number on the x-axis. We want to look at the tips. I believe it's tips. No, it's tip. I want it just colored differently by this the unique values in each of the categorical places. So let's do tips across dimension, format this, but let's change this to Violin plot just so that we can see something different. So for a Violin plot, these are the different things you can specify. Very similar. You could do facet row and facet column and all that stuff, but we just won't do that right now. So these are the different things, category orders. Majority of this would not be needed. We could try to specify the box if we want the box to be shown. So let's actually do that. Or we can run it first and then include that and see what we get. So you say a Violin plot is very similar to a box plot. They essentially do the same thing. Only difference is a Violin plot includes a little bit more, such like it also includes, say, the distribution. So what's on the side is actually the histogram, which makes a Violin plot very unique and very interesting. So let's just say box equals to true and we see what we get. So box true, and we can do this. So for this is what we find. We find this, the box is actually shown. The tips, we do have that case of where it was 10 and it was for a male. We can see here because we identified this 10 and we knew it was just 1. So when we come here, clearly it's an outlier, because even anything above 6.5 is considered an outlier in this case. You can make the box plots just to see that yourself uniquely. But we're going to use a Violin plot here. We know that 10 tip is equals to 10 was a male. Now the question is this person a smoker? Tip is equals to 10 was also a smoker. So a smoking male gave $10. That cigarette must have been really good that day. We know it was on a Saturday and it was at dinner. Now, of course, there are other ways we can identify this without, having to go through multiple Violin plots. I just thought it was interesting to show that. We also know that this person was in a group of 3. So it's a group of 3 people. The tip ended up being $10. But the person who paid the check, it was a dinner on a Saturday, and the person was a smoker. The person who paid the check was a smoking male, or a male that smokes. A smoking male. Okay, so we have, looked at this. Now, there are other ways you can improve this. There are lots of ways you can slice and dice this. You could, instead of just looking at it this way, you could decide to exclude, say, the gender, and then perform some side-by-side plots, that way. So many things you can do to improve it. I think that this is okay in terms of making it very easy to see. And then we can look into other approaches, essentially, on how to show the interrelationship between both of them. So we've covered total bill, we've covered tip across the different dimension. Next, we can decide to look at, for the different categories, just what is the bar count, right? What is the count of the different categories? Let's look at it that way. So let's try to do that. Now, you could do it in several ways. You could decide to aggregate your data that way and then create the plots, or you could just create some basic bar plots. Several things you can do. So let's look at bar plots in this case. Let's just pick an approach. Categorical data. For this, let's look at this, the bar plots. So we could say across the different dinner or the different days of the week, what does the count look like? The count of occurrence. We could look at that, or we could just look at the basic counts and see. So let's say plot equals to px dot. Let me print this out here so I don't have to go upwards to remember what the column names are. We can see this day. And if we run this, we'll have a very basic plot. Very, very basic, but we need to add some flavor to it. Very basic. For this, we can specify different things here as well. If we wanted to include several other things, we could. But for now, let's just say this, let's give it a title. We see that the count on a Sunday is almost 80. Friday has a list count at 20, so it just gives us a better idea on different things that we have. These are other stuff you can specify. If you want to color it by bar mode is also something interesting. You can specify different options for the bar mode. By the way, if you're wondering how to get into this documentation, you can always go to the Plotly website, or, like I did here, just press your Shift tab and that works. So let's see what layers of information we're going to add here. So let's color it by the sex, and then it does the breakdown. But this to me doesn't seem very intuitive. So we can change the bar mode. And bar mode has several options. The default is relative, so it shows them relative to each other. Now, there are some other charts where it shows all of this as a percentage. You could also do that. It will take some extra computation, some extra calculation to do it in Plotly Express, but it can be done. Let's say, what are those options again? There was overlay, there was relative, group overlay, or relative. So we can come here and just say group them. So now you see how we've added much more information here. So we've looked at the day of the week, and then we decided to look at the count of the gender for those different days. We could take this further as well and break it down by, smoker versus non-smoker by supplying the facet row. Oh, my bad. It's not letting me do that. We can say smoker. Simplify this, and we see that it breaks it down. Now, if you want it to be side by side, which the space is not a lot for here, so probably wouldn't work. But if you wanted to break this down to just see the count of people coming, count of visitors across different days and different categories. So we've essentially broken it down by the gender, male or female. We also broke it down by smoker, non-smoker, and then we broke it down by day of the week. So we see for smokers, a smoker female, we had the least number of them on a Sunday, in terms of their presence. For smoker male, that's that. The least was actually on a Friday, smoker male. But for non-smokers, we have the least number of them on a Friday for both groups. So this just gives you, I need to run this again so that the title comes in. This gives you an idea of how you could actually quantify categorical data, just counting them using bar plots. Bar plots is essentially very good at counting, so that is fine. Next, we can go ahead and look at multiple charts together, right? So not just univariate. So let's say bivariate. So let's say we can look at the distribution of the scatter plots, the scatter plot of total bill and tips. We could do that and use some other metrics there. So for that we can calculate this correlation metrics. I always do this just so I can have an idea of, let's just call this bivariate, or say scatter plot of numeric continuous quantities. We can leave it like this. So I do this because just looking at this matrix of the correlation coefficients, I can already see that total bill and tip, the strong correlation of 0.675, right? We see that total bill and size, the correlation is kind of weak, which is weird. You think that, it should have a stronger correlation than this. Now, the tip and size doesn't really have that much of a correlation, but there's a correlation between total bill and tip because maybe, for example, people give a certain percentage of the total bill as a tip, just by default, most times like 10%. So I think that might be what's responsible for this number. Although it could be higher, it could be 0.9, it could be 0.8. It's not that strong, but it is something. So let's go ahead and try to do this. Let's make a scatter plot of total bill versus tip and see what we find. So to do that, we can call it plot. We're going to use the scatter function, specify the data frame, df. On our x-axis, we want the total bill. Let's say total bill. And on the y-axis, want the tip. If we do this, this is what we find. So you see there is a kind of, of course, linear relationship, and we're not surprised by that because the correlation, my goodness, coefficient was 0.67. Great. What if we did some more to it? How about we specify the size parameter? I want it to be sized by the, what's the name of that? Size. Okay, yeah. If you do this, we see that it changes the whole story. So how big each of this is represents the size of people in that group that provided the tip. So we start to see, there's differences as well. Okay, let's say we want to look at it in a facet row and say break it down by smoker versus non-smoker. We could do that. And we still see for non-smoker, it's a little more total bill. So it's not, this follows more of a streamlined straight line, although you still have the outliers that act a little weird, but we see that this kind of follows a little bit of that than for this. So that's an option if you want to include that. Let's just take it out. You could also include it in another way. So let's paste this there. Oh, my bad. Pasted the wrong thing. It's okay. Next, we can color it by the gender. So let's rerun this and color by. Okay, so this is what we see. Let's include that facet row again. Facet underscore row. I want it to be by smoker. Okay, and of course you can tick this, font see only female and see only male across this. So these are just different ways you can make your scatter plots to convey different information. Personally, I don't use this facet row too much just because, I prefer when everything is together just because the visual is a little bigger, but you can do it if you want to do it. So let's give this a title, plot of tips versus total bill showing the size of group and gender. It's a very long descriptive title. Hey, at least we all know what we're looking at. So that goes back to this. We see that the tip of 10 was by the male. You could do a facet row across the day of the week. You could do it across smoker versus non-smoker. We could even take this instead and color it by smoker versus non-smoker instead, and then see what that would be. So instead of, okay, we see that 10 value of 10 tip was by a smoker, and yeah, that's the limit of a scatter plot. A scatter plot, you are able to show about 4 dimensions. So of course, tip, total bill, smoker by the colors, and then the size. So if we were to take the size out, it will look very different. Now you might want yours to be a little more simple like this, but I always think, whenever you can show difference by the size of a scatter plots, I think you should go ahead and do so. So let's do it that way. That way I already know, okay, this is a big tip, a big group, 6. Okay, big group of 6. It starts to show all of that. The scatter plots of the total bill versus the tip. Now, of course, if you have other, for example, other numeric values, you could also use this as well to look at the relationship. We can look at the relationship in a tree map as well to see how the total bill is spread across the different days and all those kind of stuff. So yeah, for this basic data set. So we've looked at the distributions of the individual things. We've also looked at bar counts. We can go ahead and just look at scatter plots, which we've done. So let's look at breakdown using something like a tree map, right? So let me create a new section here, map. It's just an example of how you can use a tree map in Plotly. Okay, so for tree map, so this has some of the values you get in there. You can specify the names and the values. So the names, for you to use a tree map, you need to specify, how you want it to be, or the path. You can specify the path. How do you want it to be broken down, and then specify the values. So let's specify values of total bill, and then let's specify the path. We want it to, sorry, this should be a list showing, you know, what we are moving from as we go. So let me just go copy all that categorical stuff we did. Okay, here you go. We're going to simplify it in here. Oh, okay, we don't need double. We can do this, do this. Okay, we do this. Let's say we break it down. You can see how this is. Play around with the part and see what we get. Okay, we can start with smoker versus non-smoker. Sorry, gender, male, female, and then break it down by day, time, all this different stuff. Oh, that even brings me to say this plot would also vary by, you know, the time of the day as well. So what you could even do for this is, we've done all this. We're only looking at 1, 2, 3, 4, about 4 dimensions at once. You could change it, and instead of looking at smoker versus non-smoker, you could look at the gender, you could look at the time as well. So there's just so much that can be done. Let's see what this gives us. Okay, already we see that the total bill comes to about 3,200 and something for male, and then it comes to about this for female. So how about we do this by the day instead of that? So let's cut this out so it breaks it down by the day first. So Saturday, majority are male, then small female, Sunday, this, you know, all of that. And well, size might not be something very informative for us, so let's take this out and just look at it. The day, Saturday, Sunday, Thursday, Friday. You see, not a lot of money is made on Friday, and you know, this versus that. Maybe we should do, let's do it this way. Okay, so smoker versus non-smoker. We see on Sunday there's a bigger box for non-smoker. On Saturday we have kind of like an equal box between both of them. Thursday we have non-smokers quite significant as well. And yeah, this is what we have for this entire thing. So this is just a tree map showing the distribution, or showing this breakdown of the total bill across the different segments. Let's call it showing break of total bill across the different segments. So that's what we have here. You can of course click into it and it shows you all these values very easily. Very, very useful, especially when you want to do some kind of summation. Okay, let's look at it for the tip. Okay, so instead of total bill, let's look at the tip and see what the total tip looks like. So say majority of the tip comes on the weekend, Saturday or Sunday. Very little on Friday. That might have something to do with not a lot of people coming out on Friday, right? On Thursday. So this just gives you a sense of it. Definitely go around, see what it looks like when you change the order in this list. And yeah, at this point I think we've done quite a bit with this data set. We've looked at scatter plots, we've looked at tree maps, we've looked at bar charts to show counts, we've looked at Violin plots, I've looked at box plots and histograms. So these are just some basic kind of visuals. Like, of course, there's a whole lot more you can do when you're trying to analyze this kind of data set. You might want to do more group bys, you might want to do some more detailed analysis, you might want to create bar charts that are percentage driven and not just relative counts, which is what Plotly does. It's a lot you can do. For now, I think this is fine and this is a good stopping point. I know this video is already very long, so I'm just gonna post this and we'll look at another data set. Now, if you have any data sets that you want to share or you want me to do a cover of, then please, by all means, just put in the comment below and I would happily go create some visuals, some cool visuals using Plotly Express. Now, if you want me to create these same visuals using, let's say, Seaborn or pygal or any other alternative, let me know and I'll happily make a video of that as well. Thank you, and I'll see you next time.